So let's write a program that will ask the user for two values, and these values can then be used to calculate the area of a rectangle with those dimensions. So it's virtually the same as the program we wrote earlier on in this session. This time, however, we're going to ask for a third input. We want the user to work out for themselves what they think the area should be and enter that value in as a guess. And our program will then do a couple of things. It'll calculate the area of the rectangle for itself, and it will then check this value against the guess that the user has made. If the user has guessed correctly, so the values are the same, then the program congratulates the user and says well done. If the user is wrong, then the user needs to be told that they are wrong, so that their guess was wrong, but they might also like to know what the correct answer should have been and how much they were out by. So our function to do this then needs at least two values changing. One value to indicate if the guess was correct or not, and then another value to record what the actual true answer should have been. So in other words, the guess that the user made could be changed when it's returned back to the main program, so that it reflects what the answer should have been. So this is a program which will do exactly that. We've got our three input statements at the beginning that take in the width, the depth and a guess from the user, and then we have a function called checkGuess, which is passed these three parameters, and the value that returns from that function is stored in a local variable called accuracy. And if accuracy is 0, then that means that the guess matched the calculation that the computer arrived at by multiplying width and depth. So in other words, the two values were exactly the same, therefore the guess was correct. If accuracy isn't 0, then that means that the user's guess was slightly wrong. So they might like to know how much it was wrong, and we can use accuracy as the variable to record how far out their guess was. So for example, if we enter 5 and 6 in width and depth and the user guesses 32, the correct answer should have been 30, so therefore the answer is 2 out. But it would also be useful if the user can be told what the answer should have been. So we can pass across our guess as a reference variable, and we can then change the value of I guess if the answer that is calculated is different to what the user guessed, and that can then be reflected back in the main program because it's a by reference parameter rather than a by value parameter. So let's see this in operation. 5 meters by 6 meters, the answer should be 30. Well done, you guessed correctly, so that's fine. So let's run it this time with an incorrect answer, 5 and 6, and let's answer 32. And our program then says you were 2 out with your guess, the correct answer was 30. So let's step through the program and see what's going on. So we'll step in and we will get our first value, which is 5. Our second value, which is 6. And then we'll get our guess, which was 32. And we can see those values have come in correctly. And we're then going to jump to the accuracy function, and we're going to pass across width, depth and guess. So those are then assigned to local variables that happen to have the same name, and if I just expand that, you can then see all those local variables. So this procedure is going to do an if statement, and it's going to do a call to another function, a function to simply calculate the area. So it's just given two values and it returns an answer. So if the answer that is returned is the same as I guess, then check guess is 0. In other words, the answers are the same. If the answers are, the values are different, which in our case it will be, because 5 multiplied by 6 should be 30, and I guess was 32, then we're going to come to the else clause. So there's the calculate area function, which does simply a simple calculation and returns the value 30. So we then check in I guess against 30, and obviously there's a difference because our guess was 32. So we can then see that I difference is going to be equal to the absolute value of I guess minus calculate area. So this just enables us to get rid of the negative figures. An absolute value of minus 2 is 2. It's the magnitude of the number. So we'll just run through that, and that works fine. So I difference now has the value 2. So we can then change I guess to be equal to what the area should have been. So I guess now gets changed to 30. Okay, and check guess is equal to the difference between the two values, which was 2, so we haven't lost the fact that it was wrong. Our function then ends, and check guess had the value 2. So when it comes into this function here, accuracy, which is assigned the result of the check guess function, has the value 2. So 2 obviously isn't equal to 0, so the guess was wrong, and it outputs that we were 2 out with our guess, and the correct answer was I guess, which has the value 30 rather than 32, which was the value that we input. So the by reference has allowed this variable in the main procedure to be changed to 30 by the actual function itself. Okay, so that's quite a complicated example. I'll leave that on the screen for you for a while so that you can perhaps pause the video and copy that code, and again I will put a text file with all these bits of code onto Blackboard along with the video itself.